Yes, f of x is a function on set of real numbers. Now only data regarding f we know is the derivative of f at 0 is 1. Another function g of x is defined as f of mod x minus square root of 1 minus cos 2x by 2. And we need the nature of g of x at x equal to 0, whether it is differentiable. If it is differentiable, whether the value is 1 or 0. If it is not differentiable, then we need the reason for the non-differentiability. Is it having a sharp turn or is it having a vertical tangent? So first let us check the differentiability of g of x. Now g of x by definition will change its character because of mod x term at 0, and similarly even this term, which is 1 minus cos 2x by 2, which is simply sin x, will also have a positive sign to the right of 0 and negative sign to the left of 0. So both the parts of g of x are changing their sign at 0 on the left side and right side. So what do we do for such a function which changes its character to the right of 0 and to the left of 0? Correct. We evaluate left hand derivative and the right hand derivative. So first let us calculate g dash 0 plus. Now by definition, how is g dash 0 plus? That would be limit h tends to 0, yes, f of mod h minus mod of sin h minus f of 0 by h. Now as h tends to 0 and we are on the right side of 0, mod h is f of h only. So this value is simply limit h tends to 0, f of h. Let's bring this side f of 0 together with f of h. So it is minus f of 0 by h. How is sin h? As h is on the right side of 0. In the first quadrant, sin h is positive. So this is minus sin h by h. Now if you look at both the parts of this is already known value to us. If you look at this limit f of h minus f of 0 by h as h tends to 0 is nothing but f dash 0, right? Minus, what is this value? Limit h tends to 0 sin h by h. Yes, that is 1. But what is f dash 0 given? That is 1, and minus 1, that is 0. Right hand derivative of g at 0, the right hand derivative is 0. Now let us calculate. This is not a conclusion to say that it is differentiable. We need to evaluate even the left hand derivative. Now what is left hand derivative for g? That is g dash of 0 minus, this is by definition limit h tends to 0 and 0 h is, how is the left hand limit? By definition it is f of mod of minus h minus mod of sin of minus h minus f of 0 by 0 minus h, that is minus h is, now let's rearrange the factors. This is limit h tends to 0, f of mod of minus h is f of h minus, let's group it with f of 0 by minus h. Now sin of minus h is minus sin h within the modulus. So this is plus sin h by h. Now if you look at what is the first part, yes, as h tends to 0, f of h minus f of 0 by h will be the derivative of the function at 0. That means it is f dash 0 plus of minus sign because there is a denominator minus, plus sin h by h, as h tends to 0 is a standard limit 1. So this is minus 1 plus 1. This is also 0. Now what did we observe? The right hand derivative exists. It is 0. And the left hand derivative also exists for g, and it is also 0. Therefore, g of x is differentiable at x equal to 0. And not only differentiable, g dash of 0 is 0. So let us see which option it satisfies. Yes, it is differentiable and the derivative value is 0, right?